This next part will be about logarithms, and here's the form on the right over here. We have a logarithm with some base. It's usually 10, but it can be something like 2, 5, whatever. And then we have a variable, which would be x. So what even is a logarithm? It's basically defined as being the inverse of an exponential function. And here's one way that you can look at it. For something like y equals 2 to the power of x, we have a base that will raise to an exponent, and it'll get us some sort of answer. So I can plug in 3 for x, and my dog's being whiny, and then you're going to get an answer of 8, right? So what a logarithm does is it takes that answer that you got, and it's going to apply the logarithm, and it will give you the exponent that would have created that answer. So basically, the output for an exponential function is going to be your input for a log function, and that's how inverses work. So yeah, you kind of have to do some reverse thinking when it comes to logs. When you plug something in, you have to ask yourselves, what is the exponent that would have caused it, basically. And something that I like to remember is that logarithms usually equal the exponent. So I always think about my answer being an exponent. Okay, and then something else that we learned about inverses is that you can compose them, basically, and everything's going to undo itself, and you're going to be left with a variable. So in the first part here, if we plug in the original function into the inverse, all that stuff is going to cancel out, and we're just going to be left with x. That's like if I had log base a, plug in a to the x, boom, cancels, we're going to end up with x. Same goes if you plug in the inverse into the original. So if I had a to the power of x, and I plug in a logarithm in the exponent, everything's going to cancel, and I'll end up with x. And then below is the same thing, but with numbers, if you're able to see it better that way. And this is especially useful if you're doing a problem that involves logs that you want to get rid of the log. That's when these properties come in handy. So if I had log base 5, let's say of 2x, and that equals 3. If I want to solve for x, I can raise both sides into an exponent and have that base of 5 under there. And what's going to happen is the 5 with the log and the exponent, that's going to cancel, and we'll be left with 2x equals 5 to the power of 3. Divide both sides by 2. Let me pull down here. And then you'll get whatever answer you get there. All right, and join me in the next video for some more logarithm stuff.